All right, how's everybody doing? Hopefully break went all right. I apologize about the late upload of this video. I had it ready to go on Wednesday, but then I accidentally, during the editing process, deleted my source videos. So I had to re-record this first part. It may jump around at the second part and go back to my previous recording. But we'll get this up for you guys, hopefully help you out with your project. I know it's a little late, but hopefully it still helps some of you out. Um, So I'm going to go down to and download the files we had on Tuesday. Here's day one zip. So I'm going to start from blank sheet, blank canvas, and work all the way through from start to finish. Show you guys all the steps needed to create a HEC-RAS model. And then for project wise, I know most of you have probably started, at least hopefully most of you have already started. But I would recommend you download HEC-RAS on your personal computer if it's at all possible. I think we all saw on Thursday, or last Thursday, that the university computers have a little bit of problem with memory, and sometimes it can have some issues. So if you do use the university computers, I would recommend getting a flash drive and saving and working your project off of your flash drives. That way you make sure you don't run out of storage and you don't run into issues where your file crashes or anything due to lack of storage. That wouldn't be fun to have to restart on any of that if it gets corrupted. So make sure you get enough storage, get a flash drive. But if it is possible to work on your personal computer, it may run a little bit smoother for you. Normally, typically you'll have a better computer at home that'll process your HEC-RAS model a little bit smoother. It's pretty easy to download. It's free. Just type in HEC-RAS download into Google. Should come up first thing off the Corps of Engineers website here. You can download this first one. I believe it only works on Windows. It may work on Mac. Actually, I think it might work on Mac. I've seen some shortcuts for Mac computers, but just download that and extract it and install it, and it should be good to go. But for today, we're just going to be working off of this file. So once you get your file package downloaded, you will have to extract it to a location that you know. So I'm going to move this to a folder I just created on my desktop. So see what I did there. I pressed HEC-RAS or extract, and then I hit browse and chose my folder here. So I'm going to put it in. Oop, this is the wrong one. Desktop, HEC-RAS lecture. And I'm going to save that folder in here and extract it. All right, now that I've got my folder saved in the right spot, I can go ahead and open up HEC-RAS. I'm going to turn on my all right. Then once you got it saved in the right spot, we can go ahead and open up HEC-RAS. Nope, folder again. So I'll walk you through a few of the menu options here. Over here on this left side, you got simple open and save. Got your geometry editor inside of the main HEC-RAS window here. We've got flow data, steady flow, quasi-unsteady, and unsteady flow. Then some sediment transport options. We won't work with those. And then your run conditions on this side. Running steady flow conditions, unsteady flow conditions, and then again some sediment transport stuff and some other stuff they're adding to HEC-RAS. And this window here is pretty important. That's our RAS mapper. We'll be working in there quite a bit. And then you can view some cross-section and data and analysis of final data here on the right. So first, what we're going to do is we're going to make a new project. We're going to go to File, New Project, and then we're going to navigate to that folder that we just made. So if you're using a USB drive on the university computers, you will have to change this drive. You can see I've got my Google Drive here, 1 TB extension. Your USB drive should show up down here. Um, so if you're using a USB drive or an extension, you can select down here and then navigate to your folder. I'm gonna go to my desktop. Oh, documents, I need desktop. Um, I think it's on my OneDrive. There we go. Desktop, HEC-RAS lecture. And then we want to start our project inside this folder, the one that's got all these data files in it. So you should have your folder and then your data files listed out here. And then we're going to title the project. Make sure you use a good title, be able to find the project later. I'm going to do HEC-RAS lecture. All right. And then it should copy the file name over here to the right as well. So if you don't see anything here, if you just see a star, you will have to name your file as well. So you get the project title and then your file name. It should copy over automatically, but if it doesn't, it gives you an error. Just type in your a file name here. Once you got all that, you can hit OK and OK. So now we've got the project started. And now we're going to go ahead and start bringing in all our data. So we're going to go to HEC-RAS Mapper over here on the right and click that. And it'll open up this second window here. And again, so it's a little bit funny how this works. This is actually programmed separately. This HEC-RAS Mapper, it's a GIS software that the Corps of Engineers added to HEC-RAS separately, so it's somewhat of a separate program. So even anything that we draw in here, we will have to load back into this main window. Um, it's a little weird how it works. They are updating to HEC-RAS 2025, which should be fully integrated with the GIS software. So they're rewriting the program from scratch, so it should be a little bit more user-friendly here coming shortly, but everything we learn here will apply to the new HEC-RAS as well. So we're going to go ahead and get started here. First thing you have to do whenever you open up a new project is set your projection file. So this projection file is a geospatial coordinate system. It'll set your coordinates for your project. So any map layers you put in it, make sure they all lay on top of each other correctly in the right spot. I've got one loaded into your project file and this file. So we'll just open one up. But if you don't know what you're supposed to use for a new project, there's this link here. You can click on that and it'll bring you to a website that's got all kinds of projection files loaded on from worldwide. So if you're looking for a projection file, you might be able to find it here. If you don't know for sure, ask a more knowledgeable engineer or supervisor. They should be able to point you in the right direction for a projection file. But I'm going to go ahead and open up my projection file. Let's go into GIS data, and it's this PASPC-FT.PRJ. So that's my projection file. I believe in your guys' project, it's just named projection. So we'll open that up, hit OK. And sometimes whenever you hit OK there, it does pop up with an error saying it's corrupted or something. Don't worry about that. Normally it's fine. It's just got an issue sometimes with the projection. It's missing like a title or something. So it doesn't quite load in 100% correct, but it'll do everything it's supposed to do here in HEC-RAS. So don't worry about that. I think it does do that for your project. So don't worry. Just hit OK and skip it, and it should load in just fine. Next, we're going to load in our terrain. And that's all of our undermap. So you'll hit the right click on terrain here. Hit create new RAS terrain. And then this little plus button will allow you to add some new terrain data. So we're going to go on a terrain. We're going to open up both of these. We've got a DEM, which is a digital elevation model, and then a BEC 10-foot. So this BEC 10-foot is a 10-foot survey of our stream bathymetry. So it's a little bit more detailed underneath the stream, and then this DEM is a LiDAR. It's a large scale model that they ran LiDAR over a large area. So it's not quite as detailed. It's not quite as integrated underneath the stream bed. And then I think we saw in our lecture on Tuesday that sometimes those LiDAR pick up the tops of bridges. So this 10-foot survey should help us get our actual stream bed underneath of that. So then once you load those in, hit OK on that. It loads them into here. You can change the order of these. So you can press that little up or down arrow whenever you select something to change the order. So this order does matter. We want our more detailed survey on top and our less detailed survey on bottom. So this is not correct right now, so I want to make sure I move my 10-foot survey on top, so that gets put on top. What it does is the bottom file it'll lay first as a base map, and then it'll build the top one on top and ingrain it into it. So this order does matter. You want your more detailed survey on top and your less detailed survey on bottom. And then hit create, and it'll run a little bit here and get everything loaded in. Once you got that, you can hit close, and it loaded our survey in here. So you can see we've got high elevations and low elevations marked in different colors. So this is a image. So elevations are marked by colors. We can change the way it looks in our project here by right-clicking on the terrain over here on the left, hitting Image Display Properties, and you can change the gradient of your colors. So let's say I wanted to look a little bit more in detail in my stream bed here and see comparative elevations. I can do from a max of, let's do 650 down to 526, which I believe is our minimum elevation. And then we're going to click Create Ramp Values and hit OK. And you can see that changes my view, so I can look a little bit more in detail at my low elevations. If I wanted to make sure I was drawing in my stream bed here, I can see exactly where my stream flows, snaking around here at the bottom of the floodplain. Or you can also hit this Update Legend with View. And what that does is it changes it based on the elevations that are in your viewport. So if I zoom all the way in here, you can see it updates and shows lower elevations, or if I zoom out, it shows larger gradient. So I'm going to leave it as that so I can have a little bit of dynamic view. Next, I'm going to load in Google Maps layer. So this is helpful to pinpoint or locate the key points or recognize different features with an underlaying of what's actually going on. So I'm going to right click on map layers, add web imagery, and I'm going to add a Google hybrid image. Hit OK. And so it didn't load in right away. The reason that is because we don't have it selected over here on the left. So you can turn on any of these layers on the left. You can turn them on, you can turn them off, depending on what you want to view. But now it's over the top of my terrain data, and I don't want that. I still want to be able to see my terrain data. So I'm going to right click on the map view, or I'm going to open this up here. Press the little plus button, right click on my hybrid and image display properties. Then I'm going to decrease this opacity just a little bit down to about 30%. And I got that set, hit OK. All right, you can just go ahead and exit out of this. And then it doesn't update automatically. If you scroll in or out, it should update. So now I've got my hybrid image underneath there, so I can actually see what's going on. So now, whenever I look at it, I know that this was a road coming across here at this high elevation. So it helps identify key features and know what you're looking at. So that's pretty important to do. I like to do it right as soon as I set up my project, so that way I've always got it there if I need to figure out what I'm looking at. All right, now we've got our terrain data and everything loaded in. So we will go ahead and start drawing in our project. This project will be running a hydraulic model from the upstream dam here, which is down here. So there's a dam going across our floodplain here. We're going to model from that floodplain all the way down to just upstream of Lock Haven here. So just down here, we're going to put our end conditions down here. We've also got some tributaries coming in here. One's coming in right here. That's Fish Creek there. Then we've got two more upstream as well. So I'm going to start drawing this in. In order to do that, it's under geometries. So we're going to hit geometry. We're going to right click. We're going to do create new geometry. I'm just going to name this simple geometry. Hit enter. And then this will pop up. These are a little bit of detailed stuff on the geometry. We will do some of this later, but you can look at these settings and kind of know what you can change. We're just going to hit close for now. And then I'm going to right click on geometry again, the simple geometry I just made, and then hit edit geometry. So now we can start drawing in different features within our geometry. What we're going to start with is under 2D area, 2D flow area. We're going to start drawing in our perimeter. So you want this perimeter highlighted in pink in order to edit it. And then I'm going to make sure I've got add new feature selected. Then you just left click to start drawing in your perimeter. So I'm going to start right here at our dam and start drawing in our perimeter. And then you want to stay around high ground all the way around if you can. You want to make sure you don't want water crossing your boundary unless you've got a boundary condition there. So I'm going to stay up at high ground all the way around as I draw this in. All right, and then as I approach Fish Creek here, I'm going to draw my boundary condition or my perimeter. I'm going to cut across my river at a perpendicular angle, or cut across my tributary at a perpendicular angle. So this is important. It helps with the calculations. Anytime you're doing 1D or 2D, whenever you cross your stream, you want to make sure that you cut it at a perpendicular angle, because whenever we put our flow conditions in, our water is going to be coming in parallel to our stream, and it sets the flow conditions. The water comes in at each point along my boundary condition equally. So in real conditions, your stream is going to be flowing in just about equally along, split apart along the stream bed. So we want to make sure that we put that in roughly perpendicular to our stream bed and cut across from high ground to high ground. And then I'm going to continue drawing along high ground here. Oh. And then I went a little bit too far there. So it's okay if you go too far. You can always edit your boundary. We're going to be editing quite a bit as we go along. So I went just past our end conditions here, but I'm just going to skip that for now so I can keep drawing. I'm just going to act like I came straight across this canal, or straight across this floodplain. Like I said, again, you want to cut straight across and be perpendicular to your flow as much as possible. So you'll see me come back and edit this here in a little bit to fix that up. All right, and then we're coming across this last one here. I'm going to stay up here close to where our good terrain data is. So I'm going to come up and cut straight across my stream here. And then same thing here, try and cut perpendicular to my stream right here that's flowing down. Cut perpendicular across. And then continue on to my dam here. And then double click to finish. I'm going to name this base from my base geometry. Hit OK. And then these are a little bit of options with your computation cells, which we'll go through here in a little bit. I'm going to go back and fix my data real quick, or my parameter. So in order to edit, you'll click the little edit geometry feature button right there. Then you can double click on your boundary, And I'm going to delete this square, or this dot here. Just hit delete, 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 delete. And I'm going to fix this up so it's crossing my stream perpendicular. And that should be good there. All right, now that I've got my perimeter drawn in, I am going to go ahead and set my cell size here. So we're going to go click on Edit 2D Area Properties, and that brings up this same window again that I was in before. So I'm going to start this out at about 1,000 feet per cell, and that is really big. That is not what you'd want to run a model on. However, this is a large model, and this is my first run through, so I don't even know how high the water's going to come. I have run this model before, so did cut it a little closer than what I would my first run. But you want to draw in really wide to start with, and then as you run your model, you know where your water gets and where it doesn't, so you can start to shrink this model down to save on some compute time, because as you decrease the size of these cells, your runtime is going to get more and more. I think my final model on this one took about 30 minutes to run. So as you're running through iterations here early on, you don't want to wait 30 minutes in between each run. So I'm starting out big, and then you can refine it as you go. And then I'm going to set my Manning's in value down here to 0.04. So what this is our Manning's in throughout this entire cross section. So it'll change the Manning's in for this entire cross section. We would normally put in especially varied Manning's in, because obviously our Manning's in is not the same through our river channel as it is on our overbanks, as it is through towns or urban areas. So we want to make sure we change that. But for now, for this demonstration, we're just going to put 0.04 for the entire area. So once you've got that, you can hit generate computation points, and then I'll throw in our mesh here. So our mesh, it's good to understand a little bit what's going on behind the scenes. So it'll generate a water surface elevation for each one of these squares. So it'll be roughly the same elevation in each one of these squares. There is a little bit of a calculation that will set somewhat different elevations. However, that's a little bit more complicated. It's a special program that HEC-RAS has. But for the most part, it only runs water conservation and energy equations in from cell to cell. So anywhere this line crosses, those are the only elevations that your equation can see. So as we go refine a little bit more, you'll see what I'm talking about. But just an idea. So these black lines are really important where they're at, because the hydraulic equations can only see the elevations that are along that black line. So, but now that we've got our base geometry drawn in, we're going to start drawing in some boundary conditions. So our boundary conditions are any conditions where we got flow coming in or flow coming out. So I'm going to click on that, and I'm already in edit mode. If you're not in edit mode, you can hit this pencil up here where the stop sign is now, or you can right click and hit start editing here where the stop editing is. But I want to make sure I've got that highlighted in pink, make sure I'm editing my boundary conditions. Then I'm going to add new feature, and I'm going to draw a boundary line just outside of my starting condition here. And then double click to finish. I'm going to name this inlet. Hit enter. So naming conventions are really important. You will need to find these and know which one's which. So make sure you name them well so you can find what you're looking for. So I just drew that outside of my boundary there. So you can see it bolded my inside line right there. So that's actually where my flow conditions are coming in, is where it bolded my perimeter. So if you drew your line a little bit too far, and you see that bolded line wrapping over this edge, you want to make sure you edit your boundary condition and shrink that down, because we don't want water coming in on this edge. We just want it on this front end where we've got water flowing down from the dam. So I'm going to go ahead and continue and draw the rest of these inlet conditions along my dam, or along the rest of these inlets, sorry. This is Marsh Creek. All right, and then once you got all your boundary conditions in, you want to scroll around and double check and make sure everything's looking okay. If you've got any red dots inside your perimeter, let me go ahead and see if I can't get one to pop up here. It's not cooperating with me. It's doing a pretty good job, but we'll see some red dots later. So if you've got issues with those, fast forward a little bit, and I'll show you how to um, fix those here in a bit. All right, and then once you got all that loaded in, that's all we need for our first run through here. So we're gonna go ahead and stop editing. Do you want to save? Yes, I do. And then you can close out of this. So like I said, the RAS mapper is somewhat of a different program, so you will have to load all that geometry we just made into the main program here. We're going to hit File in our geometry editor here, sorry. It's right there. And you're going to hit File, Load Geometry, or Open Geometry, and then it should pop up right here at the top. Hit OK, and it loads everything in. You will want to make sure everything looks about right. So I've got my outlet down here. That looks good. My inlet, inlet, and inlet, inlet. They're all named right. So I'm going to go ahead and exit out of that once I've confirmed everything's correct. And then we're going to start editing our 2D flow, or our flow conditions. So in here you can edit your different flow conditions. I'm going to start with my outlet and do a normal depth condition. So what this is doing is telling my software that I want to set my outlet condition to normal depth. So you all should know roughly from class that uh, streams approach normal depth, which is calculated based on the slope, the velocity, and the end value. And theoretically, at the end of your flow, everything should approach normal depth. So that's what we're telling our computer, is just to assume that it approaches normal depth. Now, that's not always the case. We've got lots of changing conditions. Um, so sometimes you will want to choose something different for normal depth for your outlet condition, but it's the easiest to do in here. So we're going to start with that. So our friction slope, we're going to do 0.001. So that's the slope of our flow area, and then it's going to use the end values we put in before. So for inlets, we're going to do a flow hydrograph instead. And what a flow hydrograph is just if you guys remember from hydrology, it's a graph that demonstrates the water coming in and water going out. So you'll see you've got base conditions coming in, and I'll show you the graph here shortly, where it stays steady, and then you've got a flood wave that comes in that goes up and peaks and then slowly recedes. For your project, you will be inserting your flow data into this graph. I had to make the flow data, so it's a pretty simple hydrograph. I believe it just got one peak and then drops. And I've got it all mapped out there according to the runtime here in hours. So just match up those hours with your flow data. I believe if you just copy that into this first cell, it should work all right. However, for this one, we've got a DSS file, which is a HEC-RAS data storage system. So they've got an actual flood data that comes into this stream. So I'll click that select DSS file path, hit add new. We're going to go into flow data, simple 2D flows. And you can see we've got flow data for all of our streams. This is my inlet, so I'm going to select the Sawyer's Dam outflow and highlight that in blue and then hit OK. And then I will have to enter in a slope here as well. So this is just so that it can calculate my first initial inlet conditions. So this is the slope before upstream of my inlet condition. So again, you should put in actual data here if you have it, but we're just using 0.001 today for the demonstration. And then once you got all that loaded in, you should be able to hit OK. And then we've got that one loaded in, and we're going to continue and repeat that process for the rest of these. All right, and then I did want to show you the graph of the flow hydrograph. So this is from Marsh Creek. You can see we've got a base flow condition here starting out, and then we've got a flood wave coming in where it goes up, peaks, and then slowly recedes. So that's what a flow hydrograph looks like. This is in cubic feet per second. So this is the amount of flow coming in through Marsh Creek um, based on time and flow data. And again, 0.001 for our slope. Hit OK. All right. And then now we've got all our flow data loaded in. So we should be good to go to start trying to run a model here. You can also save these. So if you want to run multiple flow conditions, you can hit save unsteady flow data as. That'll let you name it. So that way if you're running like a 10-year flood or a 100-year flood, you can compare the different scenarios. But I'm all right for now. I'm just running one scenario. So I'm going to hit exit on that and then hit the little running guy up a hill there for unsteady flow simulation. Up in this top left corner of this window, we've got a geometry preprocessor and then an unsteady flow simulation. Those are the two we're going to be running today. We're not worried about sediment transport or any of these post-processing or anything. For our start condition, I believe we're doing O2, Jan 1999 to 06. So what these are is just a, a date for the program to run. So we've got in this program the DSS files that have several days worth of flow data. So we're just telling our program which of those days we actually want to run and what times we want to start it at. So we're going to do 000, 000. So that's midnight on January 2nd, 1999 to midnight January 6th, 1999. On your project, since I made my own data, it should just be whatever date it says for 0 hour. I believe it's just like the first day ever. So you will just be running from the start of the flow data to the end of the flow data. And it'll tell you if you're outside of your provided flow data. So that's what these dates are. It's just a telling your program what flow data you actually want to run within your data. Next, we've got computation interval. So the computation interval, this is a parameter that the program needs in order to calculate everything. So it's basically how long it's calculating in between each, or what's the interval that it's actually running. So we're calculating from January 2nd to January 6th. That's about 4 days. So it's going to calculate every minute of those 4 days right now with the way I've got it selected. So this is a super important parameter for the equations. So if you're having issues, you're having errors pop up, it's normally going to be this. If you haven't been, or if you aren't able to find the error in another thing that I've shown you, like the red dots and other things, um, this number is usually the problem. You can usually decrease this, and it will fix your errors that you're getting in your computation. There is an equation that will kind of tell you what size you want this. So it's based off of your cell size and your flow velocity. So if you've got really fast velocity, you'll need to decrease this time. If you've got really small cells, you'll need to decrease this time. However, decreasing this time does cost quite a bit on computation. So if I decrease this from 1 minute to 30 seconds, it'll roughly double my computation time. So you want to leave it bigger if at all possible, especially early on. But if you start getting errors, you know that it's probably this number that needs to be decreased, especially if you've decreased the size of your cells. So I'm going to leave it at 1 minute for now. And then this mapping output interval is the amount of times that it'll show on your map. So right now, every hour will be displayed on my map, which is okay for me. I don't need super detailed information on that. There is one more parameter that we need to change in here, and it's going to be found inside this little 3 ellipses here. So if you click on that, it'll open up a few more detailed options here. And these are all just different variables that the flow equations are using to calculate your flow conditions. So if you want to dive into the weeds here, you can figure out what all these do. But the one we're really worried about is going to be our initial condition time right here. So what this is, as a lot of people call it, the warm-up time or the pre-processing time. So it what it does is it runs your model at your base conditions, the very first flow condition that the hydrograph has. It runs it at that flow for the amount of time that you set. So we're going to set this to about 24 hours. So we're going to run our model at 24 hours at our base condition. So it fills up our river at our base condition before we run our flood wave through there. So obviously that would change the flow characteristics if we were running our model dry without any water in our stream when it normally does have water in there. So we're allowing it to fill up first before we put our flood wave through there. It's going to run for 24 hours and then send our flood wave. So you can set that. You want to make sure that you've got water at your first condition, getting all the way down to the end of your stream. So if you see some dry areas at the end of your stream, you may need to increase this number. And if you see that water is getting all the way down, you can try to decrease this so that way you get closer or get a smaller pre-run time and save on some calculations. Hopefully that will make sense. If not, just leave it at 24. It should be good for your project as well. Once you got on that, hit OK. All right, and then I've got everything in here now that I would like to run my flow as. So, and then up here, you can also change your geometry file and your unsteady flow. So if I had named my unsteady flow condition, it would be named right here. But since I didn't, it's just blank. And then geometry, if you've got multiple geometries, you can change them and run different geometry scenarios. So that's for comparing scenarios. And I can also save this plan and name it. So that way, if I'm running a 10-year flood or I've got pre and post construction geometries, if I've got putting a new bridge in, I can run my geometry before my bridge and my geometry after, and then I can compare the two. So this plan file is like your picker. It picks a geometry file, it picks a flow data, and then it runs those two together. But we're going to go ahead and compute this real quick. And then once that's done, we'll go into our HEC-RAS mapper again and look at our results, see what we got. All right, so we're opening the HEC-RAS mapper here. Let's go ahead and start looking at our data and see what's going on. So in order to turn on your results, over here on the left side, you'll hit the little plus button under results, and then we're going to look at our water surface area here. You can also look at your velocity, your max water depth, and then you can load in a couple that aren't in here. These three are pretty low processing power, so that's why they load these first on here. If you want to look at something else, you can click up here on the plan, right click, and then we're going to hit create new results map. And under here, under hydraulics, we can see there's all kinds of different parameters we can load in here. We've got shear stress, depth times velocity, wet cells, dry cells, invert, mesh cell size, all kinds of different things we can look at. And then you can set different flow data here. So, but we're going to just go ahead and load in our, let's do our inundation boundary. Let's see what that looks like. Add map, and then it says it's successfully loaded in. So if we select on our inundation boundary and we view it, I don't know what that one's supposed to look like there. Let's load in a different one. Let's see what we got going here. Let's load in our shear stress. Add map. All right, now we've got our shear stress, and you see everything's red. So we may not want this this spread of data here. So we're going to change our plot here. We're going to go from 0.6 to 0. And then we're going to create RAM values, hit OK. And you can see that changes a little bit better so we can see more detailed where we're looking at. And there's some dynamics to it. So it's kind of interesting. We've got high shear velocity in certain areas, and obviously this is a terrible map right now. We've got lots of jumps and different things. So you can see, and then also if I want to change the day, so this is looking at max flow at any point at any time. So this is not one single time within our flow data here. So again, we've got our flood wave coming in, and it probably peaks here before it peaks here. So this isn't showing one time within our data. It's showing our max depth at any time that the water reached at any point in time within our model here. If we want to change that, we can use this little slider. Again, you want to make sure your water surface elevation or whatever map you want to change is highlighted in pink over here. That should turn on your little scroll bar up here. We can flip through here. So this is the very first run condition after it ran that warm-up model. So you can see we've got water flowing all the way down to the end of our model through our main stream there. If you want to change the day, you can scroll through and see what happens as our flood wave starts to come in. So that's kind of how you view some results there. So now let's go ahead and dial in and look at a couple problem areas that we need to start refining. So I see one right here. We've got water jumping out of our banks here. So the reason that is because we've got our cell size way, way too big. So as our flood comes in, instead of flowing up out of the banks like it would here, it just jumps all the way across and starts filling up these low areas here. So again, like I said, your equations can only see the elevations along your grid here, along your mesh outlines. So it's not seeing that there's high ground coming through here along the edge of the river. It's just saying this is the same elevation as this, or rather, it's starting to get to the same elevation at the water surface. So it's just jumping from here to here, filling all of it up at the same level. And then you can see along that line there, it starts to stop it. It's because it knows that that's higher elevation here, and it's stopping it along that black line. So we want to make sure we refine our mesh, and we'll go through that here in a little bit. So that's a problem to look for, is whenever you've got water jumping around outside of your banks into the floodplain, or jumping over lines, or within your stream as well. You can see it's jumping around down here as well. We've got little splotchy areas, and splotchy areas within your stream could be large, too large of a mesh, or it could also be that you've got some errors with your time interval. So if you see splotchiness, but you've refined your mesh quite a bit and you think that's not the issue, it may be your computation interval. So try decreasing that and running your model and seeing if that fixes it as well. There's a couple of other things that I see are issues within this model. We've got a couple terrain issues as well. So up here at the start of our model, we've got one right here that's a huge issue. Um, we've got high ground coming in along here, which is a road crossing our floodway here. So these roads are supposed to be here, but this one right here, where we've got high ground, this red right here, that's an error, right? So it's actually picking up our bridge that goes across here, where we're supposed to be running along our stream bed. So we'll need to fix that, and I'll show you a quick fix for errors in your terrain data, where this is supposed to be a channel, but it picked up our bridge, so we've got high ground where we don't want it to be. There's a quick fix, easy tools to fix those. Again, if you have the option available, you always want to send out a survey team and get real data as much as possible, so that way you can rely on it. But there is some quick fixes in here if you've got issues like that. This one's a little bit bad as well. I think it picked up a little bit of the bridge there on the far side. And where else might we have some data issues here? We get some more stream issues here where we're triangulating data a little bit incorrectly. There's some high ground issues right there as well. And I don't know that I'm going to fix all of these in this model, but we'll do our best to try and get it running pretty smooth here. And then you can also see over here on this side by our levee here, this is a levee going across Lock Haven, keeping the water from flooding downtown Lock Haven here. And you can see we've got water jumping over the top of our levee as well. So we'll need to fix that and refine our mesh a little bit to make sure we pick up and respect this levee here as it would be treated in the real world. We want to match real world conditions as much as possible. All right, so now that we've kind of gone through and looked at our data and kind of analyzed some problem areas, we're going to start refining this mesh to get some better results. But before we do, what I'm going to do is I'm going to reduce the size of my mesh. You can see I drew it really wide just in case I got water out here, but if I go to my max water surface elevation, it doesn't get anywhere near this height over here. So I feel pretty safe go ahead and moving my perimeter of my 2D flow area down just a little bit, so that way I save on some compute time, right? I don't need to be calculating water equations up here when I know no water is going to get up there. So I'm going to go ahead and decrease the size of my perimeter. This is the first thing I'm going to do. So I'm going to go up here, right click on edit geometry, edit geometry. Then I'm going to go into my 2D flow areas, my perimeter, and then I can just highlight that, click on it, and then click, I'm going to edit this feature. I'm going to double click on it, and I can start dragging some of my points in. And again, on this side, we've got, like I said before, we've got this inaccurate terrain data, and I'm not too concerned about flow stuff that's happening up here.
So I'm going to go ahead and delete some of these and move this entire flow condition up. All right, and then since I moved all these up just a little bit in this area that we're not concerned about, I will need to move my boundary conditions up. So we'll go ahead and edit those too. Under boundary conditions, double click to edit, and we'll go ahead and move those up as well. Right. I couldn't figure out there for a minute how to get rid of all these extra points. What I did was just I hit stop editing and save it, and then it got rid of my extra points there. So if you do want to get rid of the extra computation points because you don't want to be computing stuff outside of your boundary or your perimeter. So just hit stop editing and regenerate it, and then you can come back in, right click, and start editing again. So after we define our perimeter a little bit, is what I'm going to do is I'm going to go in and fix my terrain a little bit. I just want to show you these tools. These are not necessary for your project. However, I just want to show you the tools that are available. So if you know that they're there and roughly how to use them, they're pretty simple tools, but you shouldn't need them for your project. We didn't go over them in class in too much detail. I don't think we went over them at all. But we'll go ahead and stop editing our geometry for a minute. Do you want to save? Yes. So we're going to go down to terrain and we're going to edit our terrain. So edit layer. So now we're editing this layer and I'm going to go ahead and turn my water surface all the way to starting conditions here. So I can see my base channel and everywhere that it needs to go. We'll zoom in over here. I believe there's an issue here, which we didn't really see all that much in ours. And actually, I may move this up to our good data here. And go back to editing the terrain. Right click. Oh, I'm already in edit mode. So in order to fix your terrain in certain key areas, like especially at this road where Marsh Creek crosses this bridge, you can see the LiDAR picked up some of this bridge here, which we don't want. So we can fix that with a really simple tool here. We're going to do, where's it at here? We're going to do add new modification layer. And we're going to do lines. And there's this little tool here. It's called channel. So this was built for this exact purpose. You're wanting to add a channel across this bridge because it's not a high ground. We're adding a channel. So I'm going to name this channel 1. All right. And then I'm just going to draw a line roughly in the center of my channel across there and then double click to finish. And then this allows me to edit my channel area. So this is making just a generic trapezoidal channel cut across that bridge, and it's using the elevations from my start and my end point in order to collect that elevation. So that's what we want. We want to match, basically take our elevation from upstream of our bridge, run it to downstream of our bridge, and then it's cutting just a generic cross here, which isn't 100% realistic, but we're doing just a rough model, and it's going to be a lot better than damming up our flow from that bridge being in there. So we're going to edit our geometry a little bit here, and I'm just going to visually try and match the stream going through here. So I'm going to do my bottom width. We're going to go a little bit wider. We're going to go, we'll do twice as wide, 40 feet. So that's looking a little better, maybe a little wider, 50. And we'll go one more, we'll go up to 60. So that's pretty close to what I think the stream bed will be underneath it there. So I'm going to leave it there. The slopes look pretty good on the side. They could be a little bit back, but I think the abutments come up just about there. And again, this is a lot of engineering judgment. If you've got better data, you should always use the accurate data. But if you don't, sometimes you just have to use engineering judgment and make it as good as possible. So that's what I'm going to do for now. Just a quick fix. Hit OK. So I'm going to go through here and fix up a few more. All right, should be good there on fixing the channel. And I did notice as I was scrolling through here, and I know that this is an issue. I was going to plan on showing you guys it. But on this levee here, we've got a similar issue where the triangulation, you can see there's a little divot in the levee here, which that's not what actually happens in real life, right? This levee is protecting against floodwaters, so it continues on, and you can go into Google Maps, or you should go out to the site and make sure that that's the case. But I'm pretty sure that that's a continuous levee there, and it doesn't have this little low point here. So if we left it like that, the low point would let water into our levee or into our levee protected area and affect our model quite a bit. So I'm going to go ahead and edit that as well. So for this one, I'm going to do modifications, add a new modification layer, lines, and I'm going to do high ground instead of channel. And then I'm going to name this levee. All right, and then it's a pretty similar tool, just like the channel editor. It'll take the start and end elevation and kind of match it along the way here. So I'm going to draw it all the way across this section that's kind of bad here. So and then again, I'm just going to kind of visually match it. Actually, that doesn't look too bad the way it is. That's pretty close to what it'll use. Hit OK. And the next step will be refining our mesh a little bit more. So I'm going to start, since I've decreased the size of my area, I feel confident that I can run a finer mesh than this with some pretty decent compute times. I'll go ahead and stop this editing. Yes, I want to save. All right, and then from here, we'll go back to our 2D flow area perimeter and right click, edit geometry, and then 2D flow area editor. And I'm going to decrease this entire net size down to maybe 600. Compute. Yes, that's fine. That's a lot better. And then you can see your cell count over here too. So it's 771 cells. I think I can go a little finer than that, so I'll do 500. And the more you do it, you'll kind of get an idea for cell count and the amount of time that's going to take to compute. We've still got a lot of refining to do, so I'm going to leave it around 1,000 for my coarse model. In a real model, you might want to refine this down a little bit more to get some more accurate results in your floodplain, but we'll leave it there for now. You can go ahead and close, and then I'm going to go back, stop editing, and save first. Now I'm going to go back, and once you do this once, you shouldn't have to load in your geometry again. Everything loads in just fine. But I'll double check and make sure we're good to go there. Make sure all my flow conditions are right. That looks about right. So we'll go ahead and hit run again. And this all stays set up as well. So I'll go ahead and hit compute. So that was pretty quick. We'll go back into our model. HEC-RAS mapper. We'll see what we got here. All right, so you can see water surface elevations looking a little bit better. The stream's flowing in here a little bit better. We still got some minor errors here. You can see we got jumps here. We'll go in and refine our stream a little bit better here shortly, but we're already looking a lot better here. So you can see our flood comes in, and we've actually got some better directional flow here, right? So you can see versus the first model, I wish I could compare it here, but you've got some more directional flows in the floodplain. We're still jumping up and over into the floodplain, but you can see now instead of blobbing a whole bunch, you've got some directional flows where as you progress through, it's actually starting to fill up the floodplain in a specific manner. Back over here, looks like our levee's doing even a little bit better now that we fixed the terrain and modified our downstream, but it'll still jump over there eventually. Um, so since that ran pretty quick, I'm actually going to go ahead and refine my mesh one more time down a little finer so that way I can get better definition in my floodplain areas. So now you can see even better the flow direction as we go through. With the larger mesh, it jumped all the way up onto the floodplain, and we're already starting to get some better results. You can see it start to fill up the floodplain and where it fills up to and how it flows out there. We're still getting jumps over our levee, and our channel's still jumping out of its banks. So let's go ahead and start fixing that with some break lines. So up here in your 2D mesh editor, go ahead and start editing, edit geometry. We'll open up 2D flow areas. I want to use break lines. So what break lines are is they force your mesh to align to this break line. So I'll draw one here on my levee first to try and enforce my levee here. And again, you want to follow the high ground. Going to name this levee. All right, and you can see it automatically tried to snap my terrain to my break line. But we want to do a little bit in that because we still don't have our break lines. This is still an open square here that's crossing our levee. We want all of our computation lines to line up with our break line. So you can try to do that a little bit better. You can hit enforce all break lines. And then you can see it lines up most of my squares pretty well. It doesn't always do a perfect job. What the program is doing is just placing these points almost equally on both sides, so that way the faces of these squares all line up with with the break line as best as possible. It doesn't do a terribly great job. Sometimes you'll have to go in and manually fix it. There's different things that the program doesn't like that can cause issues, like sharp corners in your break lines can cause issues. Um, and, uh, and break lines really close to each other can also cause some issues during calculation. I may continue this down a little bit too, so that way we get closer to our edge there. Make sure that's enforced there. Again, so your equations can only see what's on the cells here. So this equation may seep over the ridge there just a little bit um, and cause some issues. So we'll refine that just a little bit more and then double click to finish. So I've got my levee in there. Then there's a couple other deep, high ground areas that are of pretty big concern that you want to make sure you get dialed in. Like roads here. For instance, this road here crossing my stream, you can see there's high ground going all the way up to the bridge that crosses the stream. So that's going to affect how our water flows through this area. It's going to get pinched into this main stream. Even water that's flowing along this floodplain is going to get pinched back in. and have to flow down the main stream channel through this roadway. So we're going to draw a break line across that roadway. We don't want to break our stream. I mean, it's okay if you do, but we're going to refine our stream later, so it's going to make things a little bit harder later if we do that. But we'll go ahead and do another break line. Add new feature, and we'll start a little bit past that one and draw a line along our top of our road. I'll just name this road 1. And then I'm going to go through and refine a few more break lines in key areas here. All right, and from there, we will go ahead and run our model to see where we're at, how things are looking, what we've improved, if there's any more issues we spot. So I'm going to hit. Oh, I forgot to enforce my break lines. That's one thing. So I will enforce my break lines and then rerun it. All right, should have a little bit better results here. We'll go down and look at our levee because that's the easiest one to see what's going on here. So with our levee line enforced, let's go ahead and look through here, see how we're flowing up. So we're pooling up quite a bit, almost all the way up. We do still have a break here, which I'm curious what that's from because we shouldn't be breaking over there. But you can see it was from one single point there that it started spilling over. So let's inspect it and see what's going on here. Oh, there it is. That's what it's coming from. We do have some low ground here. I think this is a railroad track. So that when the survey was taken, this is actually is a low area, but whenever a flood comes through, they have a flood wall that goes up here, blocks the railroad track so no railways can come through. But obviously they're not coming through during a flood anyways. But that way the levee's patched in, so that way they didn't have to rebuild the railroad whenever they built the levee. So if I wanted to fix that, I could build in some terrain there and go over the railroad track just like the flood wall would have during a flood, but I'm not too worried about it. This is a simple, just demonstration model. But we'll go ahead and keep on going. We filled up a lot more than what we did before, or a lot less, sorry. And you can see we're starting to backfill this channel instead of forward fill it because we're able to see that this isn't coming in. So we've got water coming in this side and it's spilling all the way around instead of just jumping over everywhere. We've just got one low point here, and that's actually what it would look like if we had a break. We'd normally want a little bit more refined meshes, which I'm actually going to do. I'm going to refine this down even further because I'm still getting really good run times. All right, and then from here, I'm going to continue refining now I'm going to refine my channel even more. I'm going to use a break line to do that. Or actually, I'm going to use a refinement region and enforce my break lines. So that way I can show you refinement regions. So these are all tools. Their only purpose is to change your mesh and the way it is aligned with your terrain. So you can use these for anything. I'm sure people use it for a multitude of items. There's lots of different cool tools in here. I did forget to show you on these break lines, there is a near repeat option. So I'll go ahead and show you how to work those. So on the break lines, we'll go in break lines. And then you can do, let's see here. edit breakline properties. So there's breakline properties in here, and I'm going to zoom into the levee because I know what that one's named. This is why naming conventions are really important. If I was doing this for real, I would have named each of these with their road names so I could identify exactly which one I'm editing in here. But for now, let's go ahead and edit the levee, edit breakline properties. So on the levee, we've got near repeats and near spacing. So what the near spacing is that's the cell size that I'm going to add here. So if I wanted to add a 100-foot cell, or let's do a 30-foot cell. And then the near repeats is the number of times that it's going to space out. So what I'm doing here is I'm adding cells along the outside of this break line. So it's going to add cells on both sides of the break line as many times as I type in here. So let's type in, let's do two. Two near repeats on this, hit OK, and then we're going to reinforce the break lines. So see how that added a bunch of really fine cells around my break line there? So that's really important, especially, actually, we probably want to leave that like that, to be honest, because then it shows the flow conditions coming up to this levee and going around it and how everything is moving around this levee. Um, Especially through here, if this was a channel, it would allow it to flow through that channel a little bit better, a little bit more smooth, because again, all the computer's seeing is on these black lines for the continuity equations. And we're going to do a similar thing on our stream channel here to redefine our stream channel, keep our river in our stream channel as long as it stays in, and then flow out of it a little bit smoother as well whenever it starts overtopping the banks. So we'll go into, and we're going to use a refinement region for this. So I'm editing my refinement region. I'm going to decrease my water surface elevation so I can see the stream. Go back to start conditions. There we are. All right, and then what a refinement region is you draw a box instead of a line. So let's see here. Let's do refinement region, new property, or new line. They're going to draw a box around your stream at your stream banks. All right, and refinement region, we're going to name this stream. All right, and then as I was going through, I actually changed my mind a little bit on how I want to do this. Again, these are all just tools. The main thing that matters is your mesh, so you can use the tools however you like. If you find a more efficient way, you might want to change it up and do it your own way, just using the tools to the best ability. But I'm going to, instead of using this as my break lines, I'm going to draw in another break line in here. I'm going to expand this to include all of these little areas so I can increase my resolution here in all these super low lying areas that start to fill up as the water gets higher so I can see everything that's going on. All right, once you got your refinement region set to the way you want it, you can go right click on refinement regions. We're going to do edit refinement region properties, and under stream, we're going to decrease our cell size inside. So we're going to make our X size, we're going to do 30 again. Seems like a decent size, 30. Perimeter spacing. So what the perimeter spacing is that's what I was going to do, is what it does is it sets cells around your perimeter, which I may still do because a lot of it will be useful, but it may run into some issues calculating, but I'm going to do my perimeter spacing a little bit bigger. We'll do 40. And then near repeats, we'll do 1. Hit OK. And then I will have to reinforce my refinement regions, force all regions. You see that makes a bunch of little tiny squares inside. So this is a lot better refinement inside our stream area. And it aligns the outside with the outside of my area. So you know how I tried to draw it in on all my high ground. That's why I did that, because then I can refine that exterior high ground and keep it all lined up with the black lines. But now I want uh, my boxes all lined up with the stream to be perpendicular to the stream, because that helps with calculations and everything. If at all possible, you want your calculation lines perpendicular to, or your computation lines to be perpendicular to your stream line. So how I'm going to do that is I'm going to use and I'm just going to do this in the main channel. I'm not going to worry about all these exterior channels, all these contributaries. But how I would do that is I'm going to take a break line. I'm going to make a new break line. I'm going to draw a break line down the center line of my stream. And then I'm going to put a near repeat to the extents of my stream bed here. So I'm going to draw that real quick. I'm going to go and edit the properties, the break line properties, and my stream. I'm going to do near spacing. Actually, I'm just going to do near repeats, see if it lets me do that. Let's do 10. Okay. And then we're going to reinforce all break lines. All right, so see how that just it just lined everything up with my stream. Kept my break lines in order, intact, but lined all of them up with my stream. So that's what my near repeats just took all my cell sizes around and lined them up correctly. Actually, again, since I've had pretty decent compute times, I'm actually going to decrease this size even smaller. Because normally you would decrease it smaller. Even this external area is quite large for a real model. Um, with increasing complexity, you want to slowly refine your model down so you got smaller and smaller sizes, longer run times, but better results. But since we're getting closer, I'm okay with a little bit longer run time. So now we've got quite a few of our errors here. And it looks like they're all on the outside of our stream here, because we've got more than 8 faces. The reason these little red dots come up is because we've got more than 8 faces. This block has got 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. I'm pretty sure all these have the same thing. So the reason that's happening is because we're going from a really small cell size to a really big cell size. So all these little small cells have a whole bunch of they're adding a whole bunch of faces to these big ones. We can kind of reduce that error because I don't want to go through here and hand edit all of these. That's quite a few. I probably will still have to do a few, but I'm going to try and fix a few with just my setup conditions. All right, so that got rid of most of them. Again, it's a little bit of a play in progress here, but you do want to try and get rid of, if you got a whole bunch, I would adjust your parameters of your refinement region and your break lines to try and get a little bit less, because it's a little tedious to manually edit all of these. And so learning how to play with your tools is pretty useful. And like I said, they're all tools. I'm still learning them as well. So I had to play around with it a little bit in order to get it to where I wanted it. But I am okay there. I can go through and manually edit the rest of these, um, to get rid of my errors. So in order to do that, we'll go ahead and go into computation points. I'm going to go and find all of these spots that have more than one cell, and I'm going to add a few cells here. So adding one there broke this up into two and made it not 8 sides. So I'm going to go through and do that with the rest of these. All right, and then once you got everything fixed up, you've gotten rid of all your 8-sided cells. You can go ahead and save and exit, and then you can open it back up again and hit edit, and it kind of refreshes that page with all the little dots. Go back and do a quick check again. Don't see any more. We'll check one more time on our other view pane. But it is important to know that as you're going through and manually editing, um, there you can't, if you try and regenerate from here. If I went to here and hit 2D floater, if I click this button, it's going to get rid of all of my manual edits. So that's why it's better if you can fix it with your tools, and set it up in a way that the computer can generate it on its own. It's a little bit easier to iterate because if I had to go in and change things now, add new break lines, and regenerate it here, I'd have to go back through and um, refix my couple of little errors that it had there by hand. So it's always better to use your tools if you can, but sometimes you got to go in and hand massage it into place. So now that I got that done, we'll go ahead and hit save. Yes. I'm going to try and run it again, but I'm going to check, on this other geometry editor here, um, one more time. We'll go open the geometry editor on this side. Oh, it's saying I still pick up a few down here that I forgot to pick up, so I'm going to go back in and fix those. All right, we're looking pretty good. All of our mesh is intact and no red dots left. So I'm going to go ahead and run it now. We'll see what we get. I had a few errors, so I decreased my computation interval down just a little bit since we added new cells. It's once again, that equation is set up. It's velocity and cell size that affects it. So if we decreased our cell size in our river channel, so we may have to decrease our computation interval as well. Right, so I let this run overnight. It did take a little bit, so we could get some decent results here. So we'll open up a HEC-RAS mapper and see what we got. All right, so you can see right away, we've already refined quite a bit. We're looking a lot better up here. We've still got a few things that jump out of our channel, so we could refine our mesh a little bit more. And it could also be my computation time is too large still. So that's why inside of our river channel, we may have some of these little jumps here. But you can see if we pan through our water surface elevation here, we've got a little bit more directional flow, and as we spill over into the floodplain here, we start at the river channel and then slowly overtop and go into the floodplain. Instead of jumping directly into the floodplain all the way up here, we've got some directional flow here. And so we figure out where it flows and how it fills up. We've also got our break lines in, so we can see that it's respecting this high ground here. We can turn on our particle tracing, and we can see as it comes up to this high ground here at this road, everything gets redirected through this main channel here. So that may be a scour issue there. We've got really high velocities, as you can see, as it shoots through there, and then we get slow velocities coming through here. And again, the equations, I don't know if I talked about this or not, but we've got several equations we can run in here. Right now we're running the simplest equation, which is easy, quick to run, and that's probably what you want to do for your guys' project and for first initial models, because it's a lot faster to run and it has less computational errors. So you want to make sure you can get it to run on the simplest equations first, and then you can use the more complex equations. And what the difference is this is not using any, doesn't use the, what do you call it, eddy equation. So there's no recirculating currents. This is just single direction currents, average currents going through here. So it does not calculate losses from eddy currents. We can turn that on, but again, it takes a lot longer to run. So first initial equations, we just want to run our main equation here. Let's go down and look at our levee down here. So it looks like our levee's still doing all right. Our flood wave hasn't gotten all the way down here yet. So let's go ahead and tick forward. You can see again, we're filling up more directionally. And our levee fills almost all the way up, but still spills over right here. And that's, I don't know if I mentioned this beforehand. Again, I had to re-record a section of this, so I'm not sure if I already mentioned this, but the reason this is happening is because there's a railroad that comes through here and crosses the levee. So normally they would put a temporary levee across here where the railroad passes to block the floodwaters from coming into this levee. But they leave the railroad at its current elevation because it would be really expensive to raise the railroad up to come up and over the levee. So they leave it at its elevation. They build the levee all the way up next to it, and then they'll put in a temporary blocker there during floodways. So that way they can keep trains rolling through on the existing railway, but still have flood protection. So if we were going to fix this up, we may put in some temporary terrain there, raise it up, and pass some water through there to keep water from passing through there. All right, and then the last thing we may have to do is to visualize our results a little bit better. We may want to put in some cross sections or some profiles of our streamline. So let's go down to a little lower flow condition. Let's go right about there. And I'm going to turn on my simple geometry here. And I already have these drawn in, so I'm going to delete these real quick. Um, so let's say we wanted to plot our profile line along our streamline. Well, we already have a line drawn in along the center line of our stream. So we can use that same line that we've already drawn in for our to align our break line to. We can just copy that over. So I'm going to go into the 2D flow areas, hit the plus button, and I'm going to click on my break lines. Then I'm going to go down here and click on the active features pane. So what that does is it lists all of my lines and any features that I have drawn in here under break lines. So I'm going to select my streamline here, and under the streamline, then I'm going to right click on it, or actually I'm going to hit Control C or Command C on Mac, and if you're using it on Mac. So Control C, so that'll copy that line that I've got there. You can also do the same thing, just click on it here on the map and Control C. And I'm going to paste that up here under my profiles. You may need to create a new layer by right clicking on features and then create new layer. Then you want to put a polyline layer. So we'll go ahead and do that. And I'm going to name this profile. Right. And then once you've got your new features layer created, you'll have to right click on it. And then I'm going to do import features. Or no, sorry. Let's see here. It was paste features. There we go. So the paste features button here. So since we copied that feature, we can go ahead and paste it into here. And that'll paste us a line, the exact same line that we had for our break line, into our features. And then once you have a feature line drawn in for your center streamline, you can right click on it. We're going to do plot profile. We're going to do water surface elevation. So that'll plot our profile line of our center line of our stream and our water surface elevation that goes along with it. So this brown line is our ground elevation, and then the blue line is our water surface elevation. So that's how you can copy a existing line over into your features to plot a profile line. You can also draw a new one. So I'm going to make a new features layer, create new layer, right click, create new layer, and a polyline layer. And then I'm going to name this cross sections. So in order to make a cross section, you can just click and draw just like we drew any of the other lines in. Make sure you're on add new feature. Then you can click across. We'll draw a cross section right there. All right. And then double click to end. And then we'll go ahead and stop editing. Yes, I want to save. So then under our cross sections, we've got our first line here. We can do the same thing. Right click on it and go to plot, water surface elevation, and that'll do the same thing. So this is our our ground elevation through our stream here, and then we come up and this is our levee up here. So that's how you'd plot a cross section of your river. And you can do the same thing with any of the rest of these, and it does plot the layer that you're on here. So if I was to go forward a little bit and have a higher water surface elevation there, and then try again to replot that, go into my cross sections, and then on my first line here, it's got it highlighted there. And I were to plot this, you can see my water surface elevation rose quite a bit there. So it depends on what you've got shown on your map. It'll plot whatever you've got shown. And that's how you'd analyze results as far as cross sections and profile lines. All right, and I think that's everything. Should wrap up there. Again, I apologize for the late video here. I had to re-record several sections and re-edit. I accidentally hit delete on my initial videos, so I had to re-record some. So if you see me change clothes, that's my previous recording. But hopefully this helps you out with your guys' project. Um, I should hopefully answered all the questions that you might have. Don't forget to like and subscribe.